Okay, I'm just going to, move the decimal a little bit by multiplying top and bottom, the top equation, bottom equation, or first equation, second equation by 100. And it's not going to get rid of all the decimals, but it's going to help me a little tiny bit. And if I multiply the top equation by 100, you get 8x plus 90y equals, and 100 is going to be 4.8 now. I know that's, for some students that's not necessary, but I like to get the integer. And it's going to be 30x, and then minus 35y, and multiply 100, it'd be 47.8. And then someone says, well, what are you going to pick to get rid of? And, it's a choice, but I'm going to pick the x to get rid of. I'm going to get rid of the x's. And what I'm going to do, I multiply by something to get, the least common multiple between 8 and 30. And I'll write this down for you. I'll erase it in a second. 8 and 30. Now let's see. If I took the 30, I could say it's 2 times 15, right? So I'm going to say 8 times 15 now, and that's going to give you 80, 120, right? Right, and again, this is 8 over here. And 8 could be written as 2 times 4, all right? So 120. All right, so let's see if we can do it. And, what times 30 would give you 120? I'm going to say the number 4, all right? Let me get my eraser out. And let's see, 8 times 15 now, right? Whoops. Okay, not that bad. I mean, 8 times 15 is 80 and 40, 120. And let me make this a minus sign over here, and let me see if I can do this. So 120x, and let's see. Well, I know it's tough, but 15 times 90 is 900 and 450, which is 1350. And let's do the bottom. Minus 120. And let's see, that's going to give me plus 140. Yeah, it's tough. And let's take a look. I'm going to do 15 times 4.8, which is going to give me 48, right? Because 10 times 4.8 is 48. And then half that number would be 24. So what do you get there? You would get 72. And let me do the minus 4 times 47.8. A little more difficult, though, isn't it? Well, I'm going to do 4 times 40, which is 160. 4 times 70. 4 times 7, which is 28. And then 4 times 0.8, which is 3.2. And I'll put that down. So what do you get there? 260, 280, 288, 291.2. I'm sorry, 191.2. All right, let me check that again. 88, 91.2, yeah. And let me do my addition now. Well, the x's disappear. By the way, I'm going to get rid of my baby arithmetic over here. The x's disappear, which is good news. Oh, by the way, I'm sorry. I forgot to put the minus sign over here. And let me see if I get that. So that's going to be what? 1490y equals, well, I got some work to do. Let me write this down. 191.2 and take 72 from it. Whoops. Well, that's 0.2 there, right? That's going to be 8. This will be 11. Let's see, 9. 1. Wow, look at that. Minus 119.2. And now I'm going to solve for y. All right? Kind of crazy, but I'll do it. And what do you get over here? Y equals minus 119.2 over 1490. And what I'm going to do, I realize somebody was like, when is this going to stop? And it's going to stop when you get to a nice number. And I'm going to say that's not a really nice looking number to me at this point. But I want to do my calculator. I'm actually going to use calculator too. I'm going to take 119.2. And I'm going to divide that by 1490. And you get 0.08. I'll put this over here. Now, someone says, is that okay to write that as an answer? And it is, because they kind of spoke to me in decimals. Now comes the next problem. How do you get the x? Well, what I'd recommend you do is go back to one of the equations, and that's up to you which one you want to do. And certainly I'm selecting one of them, and I'm going to select maybe this one over here. And I'm going to write this down for you. 8x. Now it's going to be 90 times that number. And what's that number? It's going to be 0.08. And it's not a bad thing to do. It's kind of simple. It's 7.2. And that equals 4.8. And what do you get? You get 8x. Well, let's see. That's not so bad to do, is it? So like 4.8 plus 7.2 is 5. It's 12. And then I can divide by 8. You get 12 over 8. Looking pretty good at this point, right? So what do you get? I'll divide by 4, and that would be 3 over 2, which is 1.5. Now, certainly, if you're really retentive, you can go back and check an original system. But I want to point out, we do give you an etch key, and we do it for a reason. We would like you to look at it, and we're getting these answers fine. Now, did I resort to using a calculator? Yeah, and you're going to be surprised that a calculator can do this really quickly. Now, I got to remind you that when Wells wrote the text, there were no digital calculators, none whatsoever. But the bottom line is the students were expected to do arithmetic. And by the way, their speed at which they were doing arithmetic was also measured. All right, it's amazing that the standards that the students were being held to. Nowadays, I realize a lot of students use calculators even for simple computation. And you know what? Maybe I resorted to a calculator for what's considered by Wells' standard to be a simple calculation. But you get tired sometimes, you just use it. But I'm pretty comfortable with problem number 1. We're going to move on now. Thank you.